Welcome to the lecture series of Mechanics of Solids. In this lecture, we are going to solve more example based on center of gravity of composite volumes. So let us start with the problem. So this is the example given. A frustum of cone with base diameter 10 cm and top diameter 5 cm having height 10 cm. Find the position of CG. So in this problem, a frustum of cone is given and all dimensions of the cone is given. Frustum of cone means from the top side of cone, a small cone is cut and it is removed. So here such a frustum of cone is given and it is asked to determine CG of frustum of cone. So let us start with the drawing. So this is the frustum of cone which is having base diameter 10 cm, top diameter 5 cm and height 10 cm. Now we want to find CG of this frustum of cone. So following this step, the first step is to determine the axis of symmetry if any. So if we closely observe the figure, we can find axis of symmetry parallel to y axis. So let us draw the axis of symmetry first. Here this axis is axis of symmetry which is parallel to y. So it's clear that when axis of symmetry is parallel to y axis, x bar can be easily determined. Here x bar is the total dimension of the object divided by 2. Total dimension of object is 10 cm in x-axis direction. So x bar will be. The second step is to decide the reference axis. So reference axes are so selected that the object remain in the first quadrant. So we'll select the axis of reference like this. So let us mark it. So these are the axis of reference xx and yy. Now the figure is in first quadrant. The third step is to divide the figure into simple object of which volume is already known. So this frustum of cone can be divided in two parts. First is the complete cone and the second is top cone which is removed. So let us mark it. The next step is to use the equation to work out centroid. So let us write the equation of y bar. So this is the equation through which y bar can be worked out. Here it is required to find v1, v2 and y1, y2. So let us work out this all parameters. We'll start with v1. v1 is the volume of complete cone. In order to work out v1 and v2, we require the height of the complete cone and height of top cone. So we'll use the concept of similar triangle to work out the height of top cone because it is not known to us. Here the dimension of frustum of cone is given, but this dimension is not known. So let us work it out first using the concept of similar triangle. Here the triangle OAB and OCD are similar triangle. For similar triangle, the ratio of base and altitude will remain same. So we can write AB, that is base of top triangle, divided by altitude of top triangle OE, that is equal to CD, that is base of complete cone, divided by OF, that is the altitude of complete cone. So let us write it. So AB divided by OE, that is equal to CD divided by OF. Now AB dimension is given, it is known to us, it is 5. OE that is not known, so we'll keep it as it is. CD, that is base of main cone, it is known to us, and OF, so that is total dimension. AB, that is base of top cone, the dimension is given, we know it. CD, that is base of the main cone, its dimension is also there. Now we can write OE in terms of OF. So OF is the total dimension. If we deduct 10, then we can get OE. So instead of OE, we can write OF minus 10. Now let us simplify it. On simplifying it, OF has been obtained as 20 cm and OE has been obtained as 10 cm. Now let us work out V1, V2, Y1, Y2. We'll start with V1. V1, that is volume of the complete cone. The equation of volume of cone, it is known to us, that is pi r square h by 3. Now let us equate all the value in this equation and work out V1. Here the radius of the complete cone is 5 cm and height of the complete cone is 10 plus 10, that is 20 cm. Value of V1 has been obtained as 523.6 cm cube. Now let us work out V2. The equation will remain same. Here the height of the small cone is 10 cm and diameter is half of 5, that is 2.5 cm. So let us equate all value and work out volume. Value of V2 has been obtained as 65.5 cm cube. Now let us work out Y1 and Y2. Before that, let us mark the centroid points. So this point is CG of the complete cone and this point is CG of top cone. Now let us work out the distance of these points from reference x-axis, that is distance Y1 and Y2. Let us start with Y1. Y1 is the centroidal distance of the complete cone from reference x-axis, and for cone we know that the distance is height by 4. So Y1 has been obtained as 5 cm. Now let us work out Y2. Y2, that is distance of centroid of second object from reference x-axis. So the height of this top cone is 10 cm. So the distance of centroid of this cone from base, it will be h by 4, and this distance is known to us. So total distance will be 10 plus height of this cone divided by 4. Let us write it. So this distance is Y2, that is 12.5 cm. Now let us equate all the value in equation of Y bar to get Y bar. So Y bar has been obtained as 3.93 cm. So this way we can find the centroid of such composite volume. Now let us mark the centroid in the figure. So this is the centroid of the first term of cone, which is at 3.93 cm from reference x-axis and 5 cm from reference y axis. This way such problems can be solved. So this is one problem given to you. Find the CG of volume as shown in figure. So here one cone and one hemisphere are there. You have to solve the problem. Please try it. Give your answer in the comment box, and if you face any problem, then please write in comment box. I will be there to help you. Thank you for watching this video.